Introduce the first speaker. It's Jordan Hutman from Lubbock, Texas. She's at Lubbock Christian University. Her major is biochemistry. She's worked this summer in the laboratory of Dr. Wanger, who is in the pathology and laboratory medicine department here. And she's going to speak to us an interesting title about the Lubbock Lake Project.
I'm not going to use the microphone because I don't like hearing my own voice. So I hope everyone can hear me. So that's my title. I am from Lubbock, and so this is a project that got started about 3 years ago. It started before I even got to college. And so I brought some samples down here and at the request of Dr. Wanger, and so I got to work on that. And that's fine. So I am from Lubbock, Texas. It's the home of Texas Tech University, Buddy Holly, and the 2013 Weather Channel Tell Us Weather. This is a little bit of a map of Lubbock. It's kind of cut off. So this is the southeast side of Lubbock, and it is the Lubbock Lake Project. We have playa lakes in Lubbock, which are man-made. We actually don't have lakes that are natural, and so these are all dug out and kept by the city. So this one out here is actually in the city of Wolford, but the rest of these are inside the city limits. We monitor the Canada geese migration, and it's all connecting to the E. coli found in the water, as well as the fecal samples from the Canada geese. And so once a month we go out and we collect water and goose poop from each of these 6 lakes. And to extract E. coli, we use EMV agar. It's a selective media that distinguishes between lactose fermenting of gram-negative organisms. And E. coli, it has the green sheen. Some other tests we use are the SIM test, which is sulfur, indole, and motility. And E. coli has no hydrogen sulfide, it is indole positive, and it's motile. And so this image over here shows that the E. coli grows away from the stab. And then we also use the citrate test. It is negative, so it stays green instead of changing to blue. If it could use citrate, it would change the media to blue. So for the project, when I brought the samples down here, I initially only brought 15, and then I was sent like 23 more, and then some more on their way. And so to start with, we have to extract the DNA. That's an image of the bacteria, kind of like a diagram. And so bacteria have no nucleus, so all we have to do is take away the cell wall and clean away the rest of it, so all we have is DNA. And then we use a PCR. We use the thermocycler to amplify the DNA so that we can read it. And then we've used, this summer I used this machine, it's called the Diversalab system, and it takes the PCR, the DNA that's been amplified, and it reads it on a chip, and it creates this gel image from the computer. The computer generates the gel image rather than running it on electrophoresis. And so what we're looking at I have a control sample, and then these are the hospital strains, so I use some of the hospitals so that I can compare how similar and how different they were to the samples that I brought from Lubbock. So all of the numbers correspond with the lakes from Lubbock. And then what we're looking for are ones that are similar. And so this is just one example of some samples that we saw that were more closely related than the others. And so what we found from this one set is that the lake samples were all fairly different, but then there were some that were the same, or that we distinguished as very closely similar. And so now what we're going to do is we're going to take the goose poop samples, because all of those were water samples, and so we're going to take the goose poop samples and do the same thing, extracting the E. coli and running it through the PCR machine and then the Diversalab. And then we're going to see if we can match up the goose poop E. coli to the water E. coli and see if the geese are contaminating the waters throughout Lubbock. And these are all the people that are helping.
you.